going to go ahead and solve some more problems using identities. These directions say simplify each expression, which basically means to break them down into the simplest form. And so you're going to do substitutions of the trig identities to try to do that. Now, looking at the first one, you see cosines and sines are generally the easiest form to deal with, but tangents and cotangents aren't. So you have friendly and unfriendly terms, and I consider sines, cosines friendly and the other one's not. So I'm going to leave the cosine the way it is and change the tangent by saying that it's the sine x over cosine x, and the cotangent, which is cosine x over sine x. Now, by putting 1 over tangent x, that may be able to get you where you want to go as well, but for the moment I'm just going to do it this way because there are different ways of solving these problems. Next, I want to go ahead and have common terms. So I'm going to write down sine x over sine x and cosine x over cosine x to get the common denominators. Means cosine x times sine squared x plus cosine squared x over the cosine x sine x. Now, you can see that the top is going to equal 1 by using the Pythagorean identity listed below here. So I know that this is going to equal 1. I'm just going to do a little shortcut here. And the cosine and the cosine would cancel out, so you're left with 1 over the sine x. And that's the same thing as cosecant x. Let's go to this problem. Again, friendlies and unfriendlies. So sine x plus cosine x times cosine x over sine x. Notice again, by putting 1 over tangent, it's not going to help you in simplifying. So I want to multiply top and bottom by sine x here and rewrite the whole thing. So it's going to be sine squared x plus cosine squared x all over sine x, which means, again, 1 over sine x or cosecant x. Now, you may run into dead ends. I would just cross it off and start over when you do these problems. Looking at 5 and 6, these where you have squares and plus and minus is 1 remind me of Pythagorean identities. So I'm going to look at the Pythagorean identities, and you should have your identity sheet nice and handy. And I'm going to see that the cotangent plus 1 is equal to the cosecant of x squared. And the secant squared minus 1 is equal to the tangent of theta, quantity squared. So at this point, I'm going to break these down so I can see what I'm looking at. 1 over the sine squared x times sine squared x over cosine squared x. Whoops. I'm dealing with x's here, not thetas. And therefore, those would cancel, and you're left with 1 over cosine squared x, which is the same thing as secant squared x. Not the only way to do it, but definitely looks pretty clean to me. Doing the same thing here, 1 plus tangent. If you solve for the tangent squared by subtracting 1 on both sides, it's going to be secant squared x minus 1 over 1 plus secant x. Now, at this point, you can see that you have only secants involved here, and I see that there's a difference of squares here, which means I can factor. So it becomes secant x plus 1 times secant x minus 1. And by changing these terms around, I'm going to write secant x plus 1. These are going to cancel, and you're left with 1 plus secant x minus 1. The 1's become 0, and therefore this answer is just secant x. Looking at the last problem, there's my cofunction identity, where this now is just equal to the secant of x. And now I'm going to go ahead and simplify this, so it's 1 over the cosine x over 1 over sine x by the reciprocal identities. Notice that I'm working down on all of my problems. Very important to work down instead of over. If you are working over and doing your work that way, please change, because you can keep things nice and orderly this way. At this point, you can multiply by the reciprocal of the bottom, which means that you now have this, and sine over cosine is tangent x. These require work, and there isn't one way to do them. Some lead to false ends. Others you just have to, you may be able to get to it, but it requires a little bit more work.